Hi, everyone. Welcome to my talk about IoT and DevOps. I'm trying to shove as many buzzword terms in here as possible, and I realized that I could have put as many as I wanted in here. I didn't have to stop at 2, but I thought 2 is enough. You know, 2's good, 2's great. So thanks for buying into the hype and showing up. But this is really a talk about my 1988 Ford Bronco 2. Sorry, bait and switch. So I got this truck, and the water temperature gauge didn't work in it, and it was always at cold, and I was like, that's not gonna work for me, because I want to know if my truck's overheating. And so I went to AutoZone, and I found like a really cheap water temperature gauge thing, and I installed it. It's actually it's an analog, so it actually pushes gas and heats it up, and that's what turns the dial, which is super cool, except for like the first 5 minutes you're driving, it's at 0. So did I really trust it? Not really. So I'm like, what's the simplest solution? Well, I could go buy a digital gauge, right? So they sell digital gauges, they use digital temperature readers, it's super accurate, but it's also very expensive. And so I thought maybe, you know, if I buy the super good one where it connects to the internet and you can like get all sorts of information, like it can run up as high as $2,500. And since I bought the truck for $750, I thought maybe I don't want to have a gauge in it that's worth, for math, it's worth 2.5 times the truck. Anyway, so I also work for a company called Nebbia Technology, and we're super into helping people with Azure, Microsoft Azure, and DevOps. And I'm like, well, this would be a great rolling platform to kind of put the 2 things that I like together, or 3 things. I like my truck, I like IoT, and I like DevOps. So let's throw them all together and see what happens. So I wanted to connect. Yeah. Oh, by the way, this is the best side of the truck where it's rusty. The other side has an actual hole. So anyway, whatever. So I wanted to connect it to the internet, and I wanted to send that temperature data from the coolant from my Bronco up to the internet, and I wanted to do it in a way that was stable, because I've made IoT projects before, but they've kind of sat on my desk, and I thought, you know, I send code to it from my computer, and it's not super reliable, and I would never be something that could be commercialized. So I'm like, well, you know, I want to learn how to commercialize IoT stuff. I want to learn how to actually, you know, send updates to it reliably and be able to monitor it, and all of these things that you have to think about when you want to make an IoT product, which I want to help companies do eventually. And so, you know, I want to learn those lessons on this Bronco project, as silly as it sounds. So I want to take a small pause right here and put this up here. This is the Q&A. You know, we may have time at the end, but if we don't, this is how you can send me questions. I can see them in real time. So if you have a question about something I'm talking about at the moment, you know, this is a good way to get it in. So you just take 30 seconds to go in there, and once I see a question, then I'll move on. But while you're doing that, I'll talk a little bit about more about my project. So in the Bronco, there's a temperature sensor already in there, and it's analog. And I wanted to put a digital temperature sensor in there, but I'm a software developer, so I don't really know anything about hardware. So it's been really a journey. And this is where I'm at currently with the mess of wires and projects right here, hardware-wise. So I have a Raspberry Pi hooked up to a physical sensor, outputting to a screen. And I kind of prototyped it to the point where I can see temperature on here from a different sensor. This is the one that's really going to go in the truck. So it's been quite a journey, and I want to share about that journey. Cool. Somebody's already put a question there, so we'll revisit it at the end if we need to. So one of the things I wanted to really focus on in this project is getting the DevOps pieces of it done really well. And DevOps is basically taking the developers and the operations who historically haven't really worked together all that well, and kind of shoving them together, because developers they write code, they want to introduce change, and operations people, they want to keep things stable. So you got a group over here and they're like, oh yeah, let's make a new feature. And this group's over here like, oh God, please don't change any settings. And historically they've been kind of at odds. So is there a way that they can work together? Is there a way that these two groups of people who are historically diametrically opposed, could we get these groups of people to somehow come to like a compromise? You know what I'm saying? So that's the big promise that DevOps fulfills, is we take these two groups of people who have, historically been at odds, and maybe we can help both groups. So maybe we can deliver faster and also have more reliability in our infrastructure. It's not, one of the things that's hard to grasp about DevOps is that it's so nebulous, but at least Microsoft's definition is it's the union of people, process, and technology to enable continuous delivery of value to customers. And I think it's important to know that you can't go buy DevOps. DevOps isn't a role, DevOps isn't a person. It's kind of like, it's a culture and the artifacts that culture creates. So planting a seed is important. So if you're in an organization where you feel like getting code out to production takes a long time, is very unreliable, you could be that person that plants that seed for that culture and says, how do we shorten that timeline? How do we make this a little more smoothly? Make this happen a little more smoothly. And it incorporates all the pieces of the loop. I know it's like an infinite loop, but it's a loop. So DevOps is part of planning. DevOps is part of dev and test. It is part of continuous delivery. And then once you deliver it, learning from that and being able to take that knowledge and make a hypothesis in planning so that when you make a change, it's an informed change, and then you can test it, and then you can deliver it again. So it's always happening. And the faster that you can make that happen, the more routine it becomes. So rather than doing this all the way around the loop every 6 months, like maybe happened in the 90s, you want to do this every day or so. So the faster you can do it, the more routine it becomes, the easier it gets, the happier everybody is, because you can introduce change quickly for the developers. And then the more you do it, the more stable the system becomes, because you're only making incremental changes instead of large, big, sweeping changes. And there's a whole bunch of theory and products and everything that goes into every piece of this. It's a very short talk today, and so I'm only going to be talking about a piece of it. So let's talk about IoT. I think there's a lot of misconceptions about IoT too. So basically, it's when you have a thing, and it's reading the real world, like from a sensor, or it's interacting with the real world, like with a motor, and there's not really a human pushing the buttons. So this is inputs and outputs. Just like with your computer, you have an input of a keyboard and an output of a screen, so you can have an interface with the computer. In this case, it's the real world. The real world is interacting with your computer. And then what makes it the Internet of Things is once you get that information from the real world, you can send it to the internet, so you can remotely interact with it, and then send back ways to do something to the real world. So what that talk earlier in this room, if you were still in here, about machine learning and AI, that ties into this very tightly, because you could have AI or machine learning in the cloud, and then you really take the people out of the process from the day-to-day, and maybe the cloud is making decisions about how the real world works, and we all get to lounge back and toast marshmallows instead of opening and closing gates to get in the parking lot. Contemporary resort. So anyway, IoT needs all of this, but we're going to talk about continuous delivery specifically and how I approached that part of it in my Bronco projects. So some of the tools that are available for other types of development are kind of established. Yeah, there's competing tools. Yeah, there's different ideas about how to do it. Yes, there's still complexity. This is the bread and butter of the company I work for, is going and helping people with that complexity. But at the end of the day, it's still a fairly mature but changing process. So building and testing, and then for web development, throwing it at the cloud, and then the cloud worries about how it gets to millions of users through web browsers. It's fairly standard practice. So, that's kind of, you can go out and read blogs about how to do it in your particular stack. And, there's experts out there who know what they're talking about. And it's really great. And also the cloud's a really nice place to put code because it infinitely scales. It's rarely down. It's pretty secure. I know the Azure, I'm a Microsoft guy through and through, so I know Azure has like literal armed guards outside of their, cloud infrastructure. So it's a cool place to deliver code to. And same is true of AWS and Google Cloud and other cloud providers too. Pretty stable, pretty easy to understand. And the same is true of app development. We have a very solid foundation of how to do this. You build it, you test it, you throw it at a store, and then it goes out to millions of devices and it updates them. And the store is also rarely down, and it's pretty secure, and it just is a magic box. But with IoT development, that story is not quite clear yet. We're maturing in the space. There is definitely things you can buy out there that are on the Internet of Things. I have a Google Nest at home, and it's very secure, I hope, and it's pretty stable, and it works, and it gets updates, and everything's fine. But there isn't like a clear way of how they develop that. I have no idea how they develop that. So I have some idea, that's why I'm talking here today. But I don't have I'm not in the code base. So there's more than one option here, and that's what makes, I think, the delivery process, the DevOps part of IoT development confusing, because there's so many options. And when I say DevOps part, I mean specifically in this instance, the delivery part, the continuous delivery part of DevOps. So what do we have to fill that space? So many choices. Oh geez, there's so many, please make it stop. So the first choice, this is an actual picture of this project. As you can tell, it's a mess, right? And that's what happens when people try to make their own IoT solution. So there's many ways to do that. You can like SSH into your devices, and that you upload code and you get calls and people are like, my thing's down, and you're like, well, let me go look at it. Or you try to make your own platform with security issues popping up all the time. Or you could just run over and stick an SD card in your thousands of devices, which seems scalable. Or you could just ask nicely for people to download stuff from your GitHub page and then like compile it and put it on their own devices that you sold them. It's just, this isn't really a way to do this. Don't do this. Please don't try to make your own way of updating devices, because it's gonna be a lot of work and it's not gonna be, secure or stable. And I mean, do it for your own stuff, but not for anything a customer relies on. So there's another option too. There's like off-the-shelf platforms. There's things like Electric Imp or Particle.io, which are kind of like generic, but so applicable to a bunch of different problems, but they have like, okay, drop your code here, we'll take care of packaging it up, we'll take care of delivering it to your devices, you just have to develop the device. Oh, by the way, we have devices that you can start off of and develop, and then you can make your own boards from them, and it's really great. It's a really great system. One of the downsides, though, is that you're kind of beholden to their pricing model, you're kind of beholden to how often it updates or how secure it is, or you lose a little bit of control by abstracting away all those problems. And then you can get into, okay, well, I just want to use an off-the-shelf system, I don't want to develop something, and you can buy into a vertical like, oh, somebody sells a product that manages my trains, okay, and I just have to install it on my trains, because everyone has trains, right? So, which is great, but then that company goes out of business in 3 years, and that's not a good situation to be in either. So this is kind of the other end of the spectrum. So the first one, if you make it all yourself, is a lot of work, but you have all the control. This is the other end of the spectrum where it's not very much work, but you don't have very much control. And then there's kind of a middle ground, which I think is a healthy place to be for most enterprises, which is using the bits and pieces of a cloud platform to put together. So Google Cloud, Azure, AWS, they all offer IoT-specific solutions which take care of updating devices and making sure they're secure, communication between the device and the cloud, and all of those things. And it's a wonderful place to be, because then you can grab and other services from that cloud provider, or even mix and match cloud providers. There's no law against that, as much as the reps might say otherwise. But it's kind of like a balance between flexibility and stability, and all of these platforms are becoming more mature in how they do IoT. So this is the option I would probably say is a good one to go for if you have an enterprise and you're looking to jump into solving one of your problems in the physical space with IoT. Like, develop something on one of these cloud platforms would probably be my advice. So for me in my little Bronco project, I didn't want to get too much into the weeds. Like, I wanted to just kind of learn some of the basics of delivery. And so I wanted kind of like the child's play set of like, yeah, this is a utensil, but I'm making pancakes. That kind of. I don't want like a commercial grill. I'm not ready for that yet. So I wanted to walk before I ran, and so I know I needed a little bit of help. Not that kind of help. Clippy. So I thought, well, what if I just, treated it more like an app than an IoT thing, and I just threw it in an app store. And thankfully, this extremely strange way of dealing with IoT is supported. So I'm a Microsoft guy, love Microsoft products. So I thought, what if I just build it, test it, throw it at the Microsoft store, and then it could go to my millions of Broncos, or my single Bronco. But anyway, this is actually a supported use case. There's some strange things that you have to do to get there, but it's supported. So what are the setup? What are the things I need to make that happen? So I'm going to build a universal Windows application, because that can live in the Microsoft store. Develop it on Visual Studio, store it in GitHub, distribute it, build and distribute it through Azure Pipelines, which is like they're part of Azure DevOps. Obviously put it in the Microsoft store, and then install it on a Windows 10 IoT Core operating system. Now, how will people find this app, right? How will they download it, and how will they install it? Well, most IoT devices don't have screens, right? And they don't have keyboards, and so people may not even be around. So it's one of those things where there's a creative solution, and it's kind of hacky, but this whole time you don't know that you've been hearing from an OEM. That is an original equipment manufacturer. That's right, I, Jared Porcenaluk, am an original equipment manufacturer. And I am part of the Windows 10 IoT Core pre-install program, and that allows me to take my application that I built, my universal Windows application, and pre-install it on my own custom Windows 10 IoT Core distribution, which is free, and then install it on my device and put it in my Bronco, and it automatically gets updates from the store. And I can set it, I can configure Windows 10 IoT Core when I create it to automatically get updates for the operating system. So two birds with one stone, right? So I did become an OEM, which you have to email someone at Microsoft, like somebody's name at Microsoft. It's kind of a niche thing that they're doing, I think. But that allowed me to do that. And it is cheating. So this is definitely not something that I would recommend if you're an enterprise and you want to make your own system. If you want to make a product, sure, this is actually a pretty decent solution. But if you're working on things that you're going to manage and you're going to own as an enterprise across your enterprise, I probably wouldn't go this route, because one of the downsides of this is the Microsoft Store says it's going to take up to 24 hours to update the device. And in the world of DevOps, 24 hours is a long time to go from we put our code in the App Store to the device is updated. That's a long time to wait before you know if it works as expected. So, there's definitely some downsides to that approach, and that's why I would recommend putting together the different pieces from a Google Cloud or an Azure to do this, because I think the downsides here mean that it only fits for niche things. But so how far am I in this process, actually? Well, I selected the hardware. This is a picture, actually, of my hardware I owned and me going through the process of selecting it. Chose the further left, most powerful platform, which is Raspberry Pi 3. Of all these options, it's the most powerful anyway. I made some proof of concept code. I used something called the Seed Grove kit. It basically you put a hat on top of the Raspberry Pi, and you don't have to worry about voltage or anything. Well, in going from that to actually reading temperature from the Bronco, I learned you do have to learn a little bit about voltage, and especially weird serial communication buses and stuff. So that's been kind of a fun part of it for me as a guy who's not into hardware. So I also set up continuous integration where my code comes together and is built in Visual Studio App Center. And I found out that Visual Studio App Center, despite the name, does not automatically send stuff to Microsoft Store. So I kind of have to rebuild that part in Azure Pipelines, which is fine because I'm more comfortable with that anyway. And yeah, I joined the OEM pre-install program, which is such a process that I feel like it's an accomplishment that deserves a green check mark. And I submitted the App Store, and they accepted it. And they accepted it once, and then they kind of like stopped accepting my updates because of various reasons that arbitrarily come up when people look at the code being submitted. They're like, this doesn't mention IoT. And I'm like, well, I submitted it once, and you said it was okay, so yeah, whatever. So as I submit more to the App Store, as is the DevOps way, I'm hoping it becomes an easier and easier process. So that's what I would like to get to. So what do I have next? What do I have left to do? Oh, by the way, this is actually a screen from my prototype where it is actually reading the temperature, 77 Fahrenheit of the real world. And yeah, so what do I have left to do? I want to do unit testing, definitely a big proponent of unit testing. Big proponent of test-driven development when I'm disciplined and with clients, but when I'm working on my own stuff, kind of saving that until after I made a prototype. Definitely want to do the continuous delivery part, so that's part of me working with Azure Pipelines to make it all get built and then sent to the Microsoft Store. And then I want to actually read temperature from the Bronco, which is where this sensor comes in. I actually bought 2 sensors, and I'm like, oh, I'll just plug them in. And neither of them worked without some sort of intermediary hardware between it and the Raspberry Pi. So there's going to be a learning curve there. And then sending data to the cloud, of course, and then monitoring. And there's a whole bunch of other side things that need to happen. Like my Raspberry Pi doesn't have like a SIM card in it, so I can't just send data to the cloud all the time. So I'm going to have to batch it up, and then when I pull into my garage or whatever, once it connects to the Wi-Fi again, then send that batch data to the cloud. So it's a whole lot of things, but I'm excited. And you can follow the progress of this project. I've actually got like 7 or 8 videos and blog posts around it. How I chose hardware, why I decided to do the OEM pre-install thing, and all those different things are on my website. The code itself is on GitHub, and it's MIT licensed, so if you want to fork my code and put it in your 1988 Ford Bronco 2, you are more than welcome to. And if you want to tell me how badly the code was written, that's fine as well. And then just a little bit about the company I work for and who I am in case you want to get in touch. So Nebbia Technology is a company I work for. It's in Orlando, and we're a Microsoft Gold partner in DevOps, cloud platform, application development. We were finalists for the Microsoft Partner of the Year. And then this Enterprise IoT Beyond the Proof of Concept, I'm going to be taking some of the harder lessons I've learned from doing this and some of my other IoT projects, and I'm going to be doing a workshop in Tampa on February 12th. So if you're interested in like diving a little deeper, putting your hands into it, it's going to be me and then another person from Nebbia who knows about DevOps even more so than I would say. So if you go to nebbiatech.com, you could probably figure out how to sign up for that. And then there's my Twitter and my blog. And I got a question, which was fantastic. I got one question. We can do real questions as well, like verbal ones. So what's the easy starting for an IoT journey? And that is a great question, because I think that's one of the hardest things for me on any technology is to get started. How do I get started in this space? And for IoT, what's really handy is that there's IoT starter kits out there. And so if you have your favorite cloud platform of choice and you're comfortable working in it, if you're a developer, you can go Google or Bing. No, I don't use Bing. You can Google, cloud platform plus IoT starter kit or something like that, and things will come up. And you'll look at them and you'll be like, I don't know how to evaluate if this is a good one or not. And that's okay. You should buy it anyway. Buy the one you think is going to work best, because you're going to learn. And then you're going to learn if it's the best one, and you're going to learn why it's not, and you're going to go turn around and have to buy other things. And you'll start this wonderful journey of buying lots and lots of stuff to plug into the internet.
So with IoT, if if you're trying to connect straight away to the internet, right?
Yep.
And if there's so if you're making a variable for a person at home, would you still need an app to configure the Wi-Fi connection part of it?
That's a great question. And the answer is yes. So in the enterprise space, if you know where it's going and you know this is like if you're not selling it to a random person off a shelf, right? In the enterprise space, they have programs, especially in the Microsoft space that I'm more familiar with. I know that they have ways that at manufacturing time, you can include the credentials for the Wi-Fi of wherever it's going. And when it shows up, you just plug it into a wall and it's already connected. But if you're putting it on a shelf, if you're building a product that's going to end up on a shelf that someone's going to buy, there needs to be some way to give it the information about the local Wi-Fi. And that's where, like you said, you'd either have an app or a local web address. So sometimes on devices, they'll have a Wi-Fi chip, and you can either use the Wi-Fi chip as I'm going to connect to Wi-Fi and get internet, or you can use it to broadcast. And so a lot of times, you'll have the Wi-Fi chip broadcast at first, and then in your manual or whatever, you say, go to this web address on the box, go to this web address, and put in these credentials, which out-of-the-box credentials aren't good. But there's several ways to handle the problem. But anyway, you log in to your account, and then you connect it up, and you say, configure it that way. And this acts for mere moments like a server, like a web server. And then once you put in the credentials, then it switches over to connecting to whatever those credentials are in your Wi-Fi. And then you can manage it through the internet. So there'd be like a login on a website that you can manage your device through. That's kind of like the standard operating procedure for that sort of thing. Good question.
I have a question.
Great.
You mentioned that we need the Raspberry Pi, right, to connect. Are there any other alternatives to Raspberry Pi?
Yeah, absolutely, yeah, heck yeah. There's a million alternatives. So I chose the Raspberry Pi because I am familiar with the platform and I know that it ran Windows 10 IoT Core. So there's other devices out there that are available to prototype that run that operating system. Most notably, the Raspberry Pi has an ARM processor, and Microsoft and ARM processors have a rocky history. And the alternative would be an x86 processor from Intel, which Microsoft has a much more solid history with. And Windows 10 IoT Core can also run on x86 hardware. And you could probably run it on pretty much any x86 hardware out there, but there's specific devices that they're building the Windows 10 IoT Core operating system for. Raspberry Pi is one. I think the Intel Edison is another one. That's one that's an x86 device. And while that doesn't really give you anything exceptionally different than a Raspberry Pi, what that allows you to do is some cool things like run IoT Edge on Windows 10 IoT Core. So IoT Edge is like Microsoft's, okay, we'll run machine learning at the edge, et cetera, et cetera, et cetera. And that doesn't run on a Raspberry Pi, but it does run on like an Intel Edison or something like that. It's a topsy-turvy world, but there's tons of hardware out there. Not all of them run full-blown operating systems. Some of them run real-time operating systems because they're so small that they can't handle a full-blown Linux or a full-blown Windows operating system. And of those, there's 1,000,001 different operating systems, real-time operating systems running on 1,000,001 different pieces of hardware. And it's really just experimentation and finding out from other people like what works. I know the 8266 is pretty popular. I myself haven't worked with it, but that's another like really low-power chip that's extremely inexpensive and can get you up and going with IoT without shelling out a lot of money.
But you cannot develop a product like for a Bronco. You cannot sell that product, if I'm just understanding correctly. So everyone has to kind of develop their own Bronco.
So this would be like a prototype board. So you can people have taken the Raspberry Pi and they've taken all the components on it and they give you the information on how to do this, and they'll remove like the USB ports and the Ethernet port, and they'll add all of the different peripherals that need to be on it on a board, on one piece of silicon that then they can incorporate inside their own device, and they can manufacture 1 million of those and sell them. And so any board that you get off the internet that can connect to stuff with a bunch of crappy wires like this can eventually be, if you want to be careful about what you get if it's not super proprietary, but most of them are built with the intention of taking that and moving it to production. But to move it to production, you got to hire people who know how to draw out a PCB schematic and get the thing manufactured, which is currently not me. So, but yeah, that's a path forward. I could take this project as a proof of concept and move it to production, even if I'm starting with a consumer device like a Raspberry Pi. Does that answer your question? Maybe a thumbs up? Cool.
While you're talking about the Windows IoT core, Windows always equals to something licensing.
Oh,
so
it's free forever.
Oh, okay.
And can be commercialized for free forever. Yes.
All right, that's great.
Yep. And you can, when I say when you join the OEM pre-install program, what's cool about that is that when you build your own version of it, like out of the box, it'll have SSH on it, which is inherently a little insecure because anybody can look at that port and get in there and do it. Even if you say like, okay, I'm going to close all ports, that's fine at the operating system level, it still has the code inside the distro to be able to do SSH, and that's, not the best it could possibly be. The best it could possibly be is there's no code inside the distribution of that operating system that has SSH even available. So as the OEM, you can go in and basically checkbox what you want, what you don't want. And for production, you probably don't want SSH because you don't want anyone to have even the possibility of using it. And so that allows you to make your own version with what you need and what you don't need taken out. With what you need allowed in and what you don't need taken out. And that's really cool from let's make it thinner and more lightweight as far as the size of it on disk, and also making it a little bit more secure by removing things that you don't need in production. Well, I'm almost out of time. Thank you guys for being patient and listening. I appreciate your questions. And again, if you want to get in contact with me, Twitter is probably the best way, or through my blog. I got lots of spam coming in through the blog, so you'll have to probably not say, read your article, was great, exclamation point. Say something like, hey, Jared. Anyway. All right, well, thank you guys so much for your time. I really appreciate it.